Welcome back to the channel. Today, we are diving into carbon equivalent in welding metallurgy, one of the most important concepts for understanding weldability, cracking risk, and heat-affected zone behavior in steel fabrication. Whether you are a welding engineer, quality inspector, or fabrication student, this video will help you make sense of carbon equivalent and how to use it in your work. Carbon equivalent is a calculated value that combines carbon and other alloying elements in steel into a single measure. Instead of just looking at carbon content alone, CE converts the effect of elements like manganese, chromium, molybdenum, nickel, copper, and vanadium into an equivalent amount of carbon. A high carbon content makes steel harder and more brittle, which increases the risk of cracks, especially cold cracking, during welding. Why do professionals care about carbon equivalent? There are three main reasons. Weldability prediction. CE predicts how easy the steel is to weld without cracking or defects. Heat-affected zone hardness. Higher CE means higher hardness in the HAZ, which increases cracking risk. Preheating or post-weld heat treatment. CE helps decide whether preheating, controlled cooling, or post-weld heat treatment is needed. There are several formulas used to calculate carbon equivalent, and the formula you use depends on industry standards and the type of steel. The most commonly used formula is known as the IIW carbon equivalent formula. This formula considers the effect of carbon first, because carbon has the strongest influence on weldability. Then it adds the effect of manganese, divided by 6. After that, chromium, molybdenum, and vanadium are grouped together and divided by 5. Finally, nickel and copper are combined and divided by 15. All of these elements are added together to give one single value, called the carbon equivalent. This IIW formula is widely used in welding codes and standards to estimate how easily a steel can be welded and whether preheating or special welding precautions are required. Apart from the IIW formula, there are also other carbon equivalent formulas used in some standards. For example, the PCM formula is often used for modern low-carbon and high-strength steels. Another formula, called CET, is sometimes used in European standards. Even though the formulas are different, the purpose is always the same: to predict weldability, control cracking risk, and help engineers choose the right welding procedure. On screen, we compare different formulas, but the IIW formula is the most common one you'll encounter in welding metallurgy. As the carbon equivalent value increases, weldability decreases. When the carbon equivalent is up to 0.35, the steel has excellent weldability, and in most cases, no preheating is required. When the value falls between 0.36 and 0.40, weldability is still very good, with only minimal precautions needed. If the carbon equivalent is between 0.41 and 0.45, weldability is considered good, but some care during welding is recommended. When the value rises to 0.46 up to 0.50, weldability becomes fair, and preheating is often required to avoid cracking. Once the carbon equivalent goes above 0.50, weldability is poor. At this level, preheating and post-weld heat treatment are strongly recommended. This clearly shows that carbon equivalent is a direct indicator of cracking risk and the level of welding precautions required. Let's look at a real, practical example. Imagine you receive a steel plate along with its material test certificate, also known as an MTC. From that certificate, you note the chemical composition of the steel. The carbon content is about 0.2%. Manganese is around 1.2%. Chromium is roughly 0.3%. Nickel is about 0.1%. All other alloying elements are very small and can be ignored for this calculation. Now, using the IIW carbon equivalent method, we combine the effect of these elements into a single value. When we calculate the carbon equivalent using these values, the result comes out to approximately 0.47%. This tells us that the steel falls into the fair weldability range. In practical terms, this means welding is possible, but precautions are necessary. Preheating the material before welding is strongly recommended to reduce the risk of cracking and to ensure a sound weld. If carbon equivalent is high, several issues may occur. Higher risk of hydrogen-induced cold cracking, increased hardness in the heat-affected zone, requirement of preheat, slow cooling, low hydrogen electrodes, or post-weld heat treatment. High CE really means you can't weld, but it does mean you need a better welding plan. To wrap up, carbon equivalent is a simple number with huge impact on weld decisions. Low CE means better weldability. Higher CE means more planning, preheating, and control. If you want better weld quality, start with the CE calculation. Hit like if this helped you, subscribe for more welding metallurgy insights, and comment below with what topic you want next.